Okay, great. So I'm Jake Wharton, just kidding, actually. I'm Annyce Davis. I work as an Android developer for the Washington Post, and you get to be my guinea pigs for my very first conference talk. So we can work together to make this a success. I'll do my part by providing pertinent information, and you do your part by laughing hysterically at all my jokes. So to get started, what do we mean when we say maintainable apps? Well, I really like this definition from IEEE, and at first glance, it tends to be a little verbose, but essentially they break it down into two components. An app is maintainable if you can find bugs quickly, one, and then two, when you find those bugs and fix them, it's very unlikely that you break something else. So we're going to use that as the context for what I mean when I say developing maintainable apps. So as Android developers, why should you care about this? Isn't it just good enough that we make apps that work, we fulfill the requirements? Well, I'm going to say no, that is not good enough. It's important that we make apps that are maintainable. So what are some reasons why that's the case? Perhaps a kitten cries every time you release faulty software into the world. I don't know, that may touch some of your hearts. Maybe it's the sheer delight of our customers as they get a new feature from our apps, which is completely bug-free. But ultimately, what affects every single one of us is this: money. It costs a lot of money to make apps, and it costs even more money to maintain apps that are full of bugs. In fact, one study suggests that it costs the US economy over $50 billion, with a B, dollars per year every time there's software defects. So as a developer, you should definitely be aware of this and use that as motivation to produce quality software. Secondly, there's also what is known as the domino effect. So every time you have to fix a bug, it moves everything else back. So perhaps there was another feature that you were going to release, and now you have to push that back to account for introducing the bug fix. So now that you know why you should care about it, how can you do it? So today I'm going to talk about 4 different components to developing maintainable apps. And the very first one is your choice of libraries that you include in your applications. Secondly, we're going to talk about domain design and how that is critical in having maintainable apps. And then third, we're going to look at code quality, specifically the readability of your code. And then fourth and finally, everyone's favorite topic, testing, especially unit testing, and how that plays such a key role. So let's jump right into the libraries. How can you choose the right Android library? Why is this such a challenge for us? Well, when it comes to Android, there are just so many options. It's kind of like when you go to the chip aisle and you kind of know you want barbecue chips, but you're not sure if they should be baked or in a can if you want Pringles, and it's just so many options. And it's the same thing with our Android libraries. Almost every week, I get a notification of a new library that's going to revolutionize the way I handle immutable objects. And it's going to completely eliminate all boilerplate code that I ever write. But it's not actually the case. So how do you know which ones to include? Well, I'd like you to consider 3 factors. And the first one is documentation. What type of documentation does the library developer provide you? Second, we're going to talk about project stability, specifically the contributions to the repository. And then the third and final point, which is actually the most important, is whether or not it fulfills a need for your application. Just because it's something that all the cool kids are doing doesn't necessarily mean that you should then add that to your apps. So if you do all 3 of these things, then hopefully you will be developing amazing apps. So let's look at an example. How many people here have actually included images in their Android applications? Okay, great. I took a safe bet that pretty much everyone, right? Almost all of us have images. But how do you know which library to use? You have Volley, Picasso, Glide, Fresco, and the list goes on and on and on and on and on. So how do you make a decision? Well, you would use those 3 factors that we just talked about. How would you do it? Let's start with Volley, simply because it was closest to the left in my slide. So how does the documentation look? Well, Volley is a project from Google, and so the documentation is hosted on developer.android.com. And it's essentially one web page and 2 examples, pretty much, on how you could take advantage of their image loader and their custom image view. So if you're new to programming, you're new to Android, perhaps this isn't the best library for you. Maybe it's not enough documentation. Or if you want to do something custom, you'd have no clue how to do it based on this documentation. Then there's what I consider auxiliary documentation, and that's Stack Overflow. So before I go add a library to my project, I go look on Stack Overflow and I check out the tag. I want to know, is there a community around this library? If I have a question, is there actually someone out there who could potentially answer it? So if you look at this example, when I took this screenshot, there were a couple of questions about Volley and very few views and no answers and no votes. So maybe that might be a hint to you as a developer. People aren't that interested in using Volley anymore. I don't know. But that's something that you would want to consider when you're making your decision. What about that second piece? We talked about project stability. How could you find out how stable a particular library is? Well, you look at the repository. Most of them are open source. So here's a snapshot from Volley's. And you can see that there's essentially 1 or 2 contributors to this particular library. Every couple of weeks, they add something new. And for the most part, it looks like minor tweaks and bug fixes. So maybe they're not going to be able to assist you with any new features that you need. Now, once you've done that, you move to the third component, and that's whether or not it fulfills a need. When it comes to Volley, I need images. It puts images. So in this case, I could say, yes, that fulfills a need for me. Now, where do we go from here? Rinse and repeat. Get the rest of the libraries that you're interested in adding to your application, do the same thing, weigh the pros and cons, and then make the best decision for you. So to review this whole section, look at the documentation of libraries before you arbitrarily add them into your product. Check out the repository, see how active it is, check out how many times they're adding commits, and then really think deeply about whether or not it fulfills a need for you and your team, instead of just going along with what you think everyone else is doing. So this moves us to our second component, and that is domain design. Specifically, we're going to talk about when classes are doing too much, kind of like this guy. Like he could have stopped here, but he just, anyway. So perhaps you've seen this before. This is a snippet from a main activity class, and what do we notice? We've got animations, there's some Chromecast support fragments, and it just goes on and on and on. So in software engineering, this is what we would call a God class. It is violating the principle of single responsibility. It's trying to assume all of these different roles, and it's very hazardous to app maintainability. So what could you do about this? Well, essentially, you'd have to clean it up. And when it comes to Android, specifically in our presentation layer, we have different options available to us. So many of you have heard about MVP, the model view presenter pattern, MVVM, model view view model, and then standard object-oriented design will get you really far in having classes that are not so tightly coupled. So what's involved in applying these patterns to your classes? Well, let's look at an example. Say you have this class foo. Foo is full of dependencies. Now you decide to migrate foo to the MVP pattern. How would it work? Well, you would slowly eliminate some of foo's dependencies, and then you would spread them out among other classes and interfaces, and then you would have a system that is more decoupled, easier to test, easier to debug, and obviously more maintainable. So let's look at an example of how you could do this in Android. Remember the scary class from earlier? How could we clean something like this up? Well, first we need tests. And I know that tests can be a little scary, especially when we're dealing with a class that is so tightly coupled like that. But we could take advantage of integration or acceptance tests using Espresso or Rebodium in order to make sure that we're not breaking any existing functionality with our new changes. Now, once we've done that, we can take advantage of the tools that are available directly in Android Studio. Specifically, we see the refactoring tool where you can extract a class from another one. In this case, we're going to extract some key methods from our main activity into our presenter class. Now, once we finish this step, it's going to be a little messy at first, but we're so much closer to getting that class that is more decoupled. Next, we'll create an interface. This will act as the sort of communicator between the activity and the presenter. And then inside the presenter class, we would just reference the interface as you see here. So there's nothing Android specific in our presenter, and we're just talking between plain old Java objects and then interfaces. And once we had that in place, we could implement that interface inside of our main activity where we would have our Android specific information. So if we do all of this, then we're getting so much closer to having that type of structure that is much more maintainable, easier to debug, and easier to test. So in review, keep your code simple. Don't be like scary mustache guy. Use some type of MV something pattern, MVC, MVP, whatever you like. Take advantage of functional tests to make sure that while you're doing your refactoring, you're not breaking anything in your applications. And then also take advantage of the tools available to you. It will be a real pain to try to make all of these changes manually, but you can use the refactoring methods available through Android Studio. So let's look at our third feature there, code quality. Specifically, we're going to talk about poor readability and why that's so hazardous to app maintainability. So I like to think of it this way, that when your code is really messy, it's kind of like looking through a dirty windshield. You know there's something important out there that you need to see, but you're completely distracted by the bugs and grime all over the screen. And so when it comes to our code, we know that we spend more time reading code and editing code than we actually do writing new code. So we want that to be an enjoyable experience. So what can we do to increase our readability? Well, we can take advantage of a tool called CheckStyle. And this is just one of many tools that can help us as Java developers, Android developers. So CheckStyle allows you to get your code to adhere to a certain standard that you and your team have agreed upon. How does it work? Essentially, you see here, it takes your source files and it combines those with a XML configuration file that you specify, runs it through the engine, and then presents output to you with respect to the design, formatting, or code complexity of your applications. So how would you use it? CheckStyle is actually available as a Gradle plugin. So you just simply add it to your build.gradle file and reference it. And then you will create a task where you make a reference to the configuration file that you created. So what would the configuration file look like? Here's an example where we have the method length, and we're basically specifying that no methods in our Java classes can be longer than 60 lines. So it's very difficult to read code when you're just like scrolling and scrolling, trying to get to the end of the method and understand what's taking place. Another one, line length. You can take advantage of this to say no lines in the class can be longer than 120 characters. For example, this is like my personal pet peeve, is when I see code kind of like this. I'm just like, what were they thinking? I don't understand. Okay, so we can completely eliminate that frustration by putting limits on the line lengths in our code. And finally, one of my favorite ones, which is like a tongue twister, is the cyclomatic complexity check. And I really like this one because it allows you to keep your method simple and not have so much confusing branching logic inside of it. And so how does it work? Essentially, it's a formula that takes advantage of graphs where you come into your functions and where you exit and how many loops and case statements, etc. But it really is a great tool to help you be more concise about the code that you write. So let's look at an example of using this particular check. Say we have code like this, aptly named overly complex method. I'm sure you've probably seen something like this before, where there's a switch statement with multiple case statements, and there's code duplication, and it goes on and on and on. What would happen if you ran this code through check style? Well, you'd get a warning. Check style will let you know that the cyclomatic complexity of this code is 9, whereas you specified nothing could be greater than 8. So as a developer, what would you do? Well, the first step would be to break it up. So what I recommend in this case is I would put the switch statement in its own method, run this thing through check style again, and now I'm down to 7. So you could say, great, yay, I'm down to 7, done. No, we have code duplication, right? So if you merge the duplicate code together into one method, and then you run that through check style, you're already down to 4. So what do we see here? Readability really matters. We know, as I mentioned before, that we spend more time reading and editing than we actually do write code. We can take advantage of static code analysis tools like check style to have some sort of standard for ourselves and our entire team. And then also, it's beneficial to refactor gradually instead of going through your code and just making like huge sweeping changes and cleaning everything up, because you're more likely to break things. So let's look at our fourth and final point, unit testing. So untested code is really scary. Every time you and your team go to check in some new code, there's this nervous apprehension from everyone, like, are they gonna break the build? Because you have no test in place. You have nothing as a safety net to fall back on when you're adding new features and when you're refactoring. So I came across this quote as I was reading a book from Robert Martin, Clean Code, and he said, every single line of code that you write should be tested, period. Just think about that. I did. And at first, I was really annoyed with Robert Martin. I thought to myself, who is Robert Martin anyway? I've been writing code for over a decade, and trust me, every line of it is not tested. But I paid good money for that book, so I kept reading. I wanted to learn more about him. Well, who is he? He's the maintainer of an application called Fitness. It has over 64,000 lines of code, and almost half of that code is contained in unit tests. That's impressive. Then, those tests have at least 90% code coverage. There are over 2,200 of them, and they still all run in 90 seconds. Now, I don't know about you, but I can never say that about any of my code. So I decided I was gonna listen to Robert Martin. And I started to write tests, and lots of tests. Specifically, I took advantage of the combination of Mockito with JUnit, and I feel that that was very powerful in getting me very close to some sort of ideal code coverage standard. So how could you do this? Well, if we take that presenter class that we had extracted earlier, this is a very simple setup for using Mockito, one, to mock the collaborators. You just create your presenter, and then you go about creating a sample test. This is using very standard given, when, then structure inside the test. You make what you want to do, you call a method on the presenter, and then you verify that it was done. There's no Android kung fu happening here. This is standard Java work. Now, what do you get when you do this? You can get a class which is now fully tested. Unlike what you had before, that class was so tangled together, there was no way you could write unit tests for it. Then you can go crazy and you can add your Android application to a continuous integration server, and you can see how you're doing build after build. Are you doing better? Then, hey, use a code coverage tool. See where you need to improve. When I look here, I go, wow, I nailed it in the presenter package, but the views is really suffering. Now I know where I can focus my unit testing efforts. And finally, it just makes you powerful. Once you have tests in place as a developer, you're so confident, you just go through like, I'm changing that variable name. Because you know that you can run the test and you'll know right away whether or not it passed or failed. So to sum up this section, listen to Robert Martin. Write your unit tests. Use JUnit and Mockito. That will get you at least, I'd say, 80% of the way there. Take advantage of a continuous integration server. This makes you and your teammates accountable for keeping a high-quality build. And then finally, use a code coverage tool so that you can see where you should focus your efforts for unit testing. So in summary, choose the right libraries. Don't just throw something in because that's what you think everyone else is using. Don't do too much. Keep your classes simple and make sure you don't violate the principle of single responsibility. Ensure code quality by taking advantage of static code analysis tools, such as what we discussed today through CheckStyle. Finally, listen to Robert Martin and write your unit tests. So I'd like to leave you with this final thought, and that is this: just try. Just try. Next time you check in your code, just try to check it in a little bit more tested, a little bit more maintainable than it was when you checked it out. Thank you. So I just want to mention that I do have resources available, and I got photo creds for all those photos if you're interested. There's a hard copy of the resources available up here, and then also if you go find me on Brown Girl Dev, you can get the soft copy on my blog. So if you have questions, I'm around and you can come find me, so thanks.